machine learning approach relies on analyzing historical data to make informed decisions for both present and future situations, often discovering insights that are imperceptible to humans or challenging to express through conventional rule-based languages. Machine learning is extraordinarily powerful in environments and situations where conditions fluctuate dynamically, making it difficult to establish clear and robust rules.
Welcome back to Digi.AI.Velocity, your ultimate source for all things AI and technology. Today, we delve into DARPA's cutting-edge use of artificial intelligence in fighter jets, transforming the future of air combat. The Defense Advanced Research Projects Agency, or DARPA, has long been a leader in technological innovation, often redefining the limits of military capabilities. One of its most ambitious and revolutionary projects involves integrating AI into fighter jets, a development that could change the dynamics of aerial warfare forever. Historically, AI in military aviation was limited to basic functions such as autopilot systems and threat recognition. However, advancements in AI, machine learning, and neural networks have opened the door to far more sophisticated applications, setting the stage for the next era of air combat.
We had 8 teams compete against each other using a variety of different algorithmic approaches, learning, adapting, and evolving, mastering complex aerial tactics through countless simulated dogfights.
For that final event, you had an AI agent against a human pilot in a simulator.
They ended up sweeping all 5 matches, defeating the human in that case. However, our agents had not yet been trained to adhere to human norms, what we call training rules. These rules keep you safe when you fly. We needed to innovate new ways to enforce safety and human norms into opaque neural networks. Since our agents learned, we encoded these norms into the environment through a sequence of simulation updates. After years of painstaking development in simulation environments, it was necessary to confront the real world.
ARPA's mission to maintain U.S. military superiority is driving the push for AI integration in combat scenarios. One of the key initiatives is the AI Next campaign, launched in 2018, aiming to create AI systems that can adapt, explain their decisions, and work seamlessly with human operators. Within this broader initiative, the Air Combat Evolution (ACE) program stands out. This program is dedicated to developing AI systems capable of performing complex dogfighting maneuvers, potentially assisting or even replacing human pilots in high-stakes aerial combat. A pivotal moment in DARPA's AI journey was the Alpha Dogfight trials, a series of competitions designed to test AI pilots against human counterparts. In August 2020, an AI developed by Heron Systems faced off against a seasoned human F-16 pilot. In a stunning display of technological prowess, the AI pilot won all 5 rounds, proving that AI could outperform humans in certain air combat scenarios. This success marked a milestone, demonstrating that AI could handle the rapid decision-making and dynamic maneuvers of aerial combat.
A machine that's going to control an aircraft in real life is a difficult problem, because that machine has got access to flight control surfaces that could over-G the airplane, could break it, could do real damage. We had to have an airplane they couldn't break.
And that's where VISTA comes into the picture, the X-62.
The X-62 is a very unusual airplane. It started life as what we call an in-flight simulator. While we're flying, we can simulate just about any airplane. So to make it safe for the VISTA, they put in these things called safety trips.
On top of the safety trip system that we have on VISTA, we also have a sandbox for autonomy as well. So we have an integrated space within VISTA and the flight controls that allows for artificial intelligence agents to send commands into VISTA as if they were sending commands into a simulated model of VISTA.
So think of a simulator laboratory that you would have at a research facility. We have taken that entire simulator laboratory and crammed it into an F-16, and that is VISTA.
The Alpha Dogfight trials were just one part of the larger ACE program, which envisions a future where AI handles tactical execution, allowing human pilots to focus on strategic decisions. This human-AI partnership could enhance air combat efficiency, leveraging the speed and data processing capabilities of AI alongside human intuition and judgment. The program's phased approach begins with AI training in simulations and aims to eventually deploy these systems in real-world combat settings. The future may see AI co-pilots assisting human pilots, or even swarms of AI-controlled drones executing complex missions.
Machine learning and artificial intelligence has had to overcome is something called the sim-to-real problem.
The simulation environment still lacks a tremendous amount of fidelity from reality.
Despite the progress, several challenges must be addressed before AI can fully take to the skies. The intricate nature of air combat, with its need for rapid adaptation and nuanced decision-making, still poses significant hurdles for AI development. Integration with existing fighter jet systems, the need for robust AI-human communication, and ensuring AI's decisions are understandable and trustworthy are key technical barriers. Moreover, the ethical implications are profound. Questions of accountability, the potential for unintended consequences, and the legal ramifications of autonomous decisions in combat are all critical issues.
The incredible accomplishment of this year was to take these machine learning agents and place them into the X-62 in a real-world environment. So beginning in December of 2022, that was the first application of machine learning agents to control the flight path of fighter aircraft, a world first. In April, we then flew several AI agents.
We retrained agents on a daily basis, updated flight control laws overnight, and reprogrammed the aircraft to fly the next day. Over 100,000 lines of flight-critical software changes were made as the system evolved during flight test.
And then finally, in September 2023, we accomplished another world first,
where we actually took the X-62 and flew it against a live manned F-16. We built up in safety using the maneuvers, first defensive, then offensive, then high aspect nose-to-nose engagements, where we got as close as 2,000 feet at 1,200 miles per hour.
And while the X-62's unique safety features have been instrumental in allowing us to take elevated technical risk with these machine learning agents, in this test campaign, there were no violations of the training rules, which codify the airman's safety and ethical norms, demonstrating the potential that machine learning has for future aerospace applications.
Future combat scenarios, AI working alongside human pilots, global military implications. Looking ahead, DARPA's efforts in AI-powered fighter jets could redefine air combat. Potential applications include autonomous swarms of drones and real-time AI co-pilots assisting human operators. These advancements promise increased combat efficiency and could alter the balance of power in the skies. However, the rise of AI in military contexts also raises concerns about an AI arms race and the ethical landscape of autonomous warfare. Ensuring responsible AI development and international cooperation will be essential to harness these technologies safely. DARPA's AI-powered fighter jets are a glimpse into the future of warfare, where technology and human expertise intertwine. As these systems evolve, they offer incredible potential but also demand careful consideration of the ethical and strategic implications. Thank you for joining us today on Digi.AI.Velocity. If you found this video insightful, make sure to like, subscribe, and hit the notification bell to stay updated on the latest in AI and technology. Until next time, keep exploring the future.